right, that's fine. Here, go ahead.
All right. So, welcome to another joint meeting of the Rotary Club of Livermore and the Livermore Satellite Club evening. And I think we've got two of those members here today. Great. Wonderful to have you. We're making history on that. So here we go. Pledge of Allegiance. I think Bob Bishop, it would be appropriate to have Bob Bishop lead us in the Pledge of Allegiance. Thank you, Bob.
Please join me in the Pledge of Allegiance. I pledge
allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Well, there are not that many songs about Mars. I mean, Rocket Man, but man, that's hard to sing. So we've got this classic here, and we're going to be hearing about minerals on Mars, and maybe we'll even find out what spring is like on Mars. So let's all swing it. Okay, ready? 1, 2, 3, 4. Fly me to the moon and let me play under the stars. Let me see what spring is like on Jupiter and Mars. In other words, hold my hand. In other words, baby, kiss me. Yeah, come on now. Fill my heart with song and let me sing forevermore. You are all I long for, all I worship and adore. In other words, please be true. In other words, I am you. Fill my heart with song and let me sing forevermore. You are all I long for, all I worship and adore. In other words, please be true. In other words, I love you.
Thank you, Carolyn.
I know this is getting old. I'm like the sub-thought for the day person now. So, but as fellow Rotarians, we fill in where we're needed. So, Sheila is ill and asked me to share her thought with you. With Valentine's Day approaching, Sheila has been reflecting on what the day truly represents and how it extends far beyond candy and flowers. At its heart, Valentine's Day is for everyone. It's a reminder to slow down, appreciate the people around us, and reconnect with the values that bring meaning to our lives. Begin your day with a mindset rooted in opportunity, growth, and gratitude. Small, intentional actions, embracing new possibilities, learning from challenges, being present in each moment, create lasting happiness and momentum. Valentine's Day encourages us to remember that we shape our own experience through the choices we make and the attitude we carry. It's an invitation to lead with kindness, openness, and appreciation, not just today, but every day. So thank you, Sheila.
And thank you, Carolyn, for presenting that wonderful thought for the day. So next up, our meeting front line, Spur reporter Trudy Barnes. There's Trudy. Trudy's right over there. Spur publisher Ted Michaels, also doing AV today and throughout the week. Photographer Christine Lusty. There you are. Thank you, Christine. Audiovisual Ted Michaels on AV all week. And greeter Trudy Barnes. More frontliners. We have Sergeants at Arms, Sonia Sheffield and Debbie Peck. By the way, we're going to do a brag. We were going to do a brag this evening, but we're going to move it on to next week because we've got so much to do today. First of all, web magician Kathy Coyle. Next, public outreach. By the way, are you here, Kathy? Yeah. There you are. Great. Thanks for being web magician. I appreciate that. And public outreach, Kelly Bowers. Is Kelly here this evening? And videographer, right over there, Sonia Sheffield. So, introduction of visiting Rotarians and guests. Do we have any visiting Rotarians? Trex.
The Satellite Club people count?
Of course.
Yes.
Don't everybody boo it? Good, moving along.
Did we introduce our satellite Rotarians?
President Pat, we should decide this. Satellite Club is part of our club, but if they visit us, we should introduce them. Is that the expectation? I will do that.
Great.
Until they memorize all our names.
Nobody's going to... Okay, please stand up, James. I've been getting to know James tonight. He is a member of our Satellite Club, and he is a professional photographer. So please welcome James.
Welcome, James. Good to have you here. This is all coming together now.
Are we ready for guests?
Yes.
Okay, guests. Mom?
Christy.
I would like to introduce my mom, Dorothy Bishop, and my dad, Stan Bishop. They have an obvious connection to the guest speaker, which my sister will be introduced by somebody else, so I won't do that now.
Great. Thank you very much.
And I am very pleased to introduce my wife, Jane.
Hi, Jane.
Kelly's here. Welcome, Kelly. Just arrived on time. Great.
And President Pat, I would like to introduce my wife, Mary.
Great. Thank you, Ellen. Welcome, Mary. Good to see you. And we have an announcement. Mark Roberts gave me a call this afternoon and wanted you to know, here is my update, if you want to read it, pertaining to what happened at the City Council this past week. So on Monday, February 9th, the City Council officially named the Allen Frank Community Room in Allen's honor. So. And President Mark also wants you to know that the staff made a recommendation for the naming of the Alan Frank Community Room, and he wants everyone to know that everyone who has donated to support the Alan Frank Community Room is doing extremely well, and our fundraising we're almost reaching 90% of our goal with only 20,000 ready to make that 100%. So that's it from Mark. Next up, crab feed. Is JR nearby? Great.
Okay, so as far as the tickets go, there are 2 complete tables left and 9 seats scattered. There's 3 at one table, 4 at another, and I think 2 at another. So there aren't many seats left, and there's 2 complete tables left. So if you know anybody that wants to buy a table, they better jump on it pretty quick. Also, we have a meeting coming up tomorrow at Bob's house at 5:15. If you're involved with the committee, please attend. And we're still looking for baskets, bigger, larger baskets. So if you get those, contact me. I'll take them and put them in the right place where they're used properly. We have donation sheets over there. Please continue to bring in donated prizes, or you can donate some money for prizes. And those are for our silent auction, our live auction, and our raffle baskets. So if you have any of that, bring it. Go ahead and keep getting it. We're doing pretty good.
Sounds like you're doing great.
Oh yeah, start looking through your liquor cabinets, because me and Bob, we drink a lot, and these meetings get very stressful. So, and we're running out.
This barrel of booze coming back?
It's for our wheelbarrow of booze. So if you have any liquor you want to donate, please contact me or contact anybody on the committee, and we'll probably start collecting those about now. So if you have anything like that, please get in touch with me, or you can bring them to the meeting, and I'll happily take them from you.
Great, thank you, JR.
I think that covers everything, right? Okay. Okay, one more thing.
Just one really quick comment.
Wait.
If you donate something,
We can't hear you.
I got a big mouth.
All right, just one really important request is that if you donate something, don't just leave it and not let us know who it came from or its value, because we got a really big print that's about this big by this big, and we had absolutely no idea who donated it. And we had no idea.
He did know, but he forgot. I forgot who donated it.
Oh, so you did know?
I did know at one time. They put it in my garage.
Well, whoever did that, would they please let me know?
Okay, coming up is the next Bad Build event on Saturday, February 28th.
Pat, I got it.
Thank you,
Okay,
Felix.
so last week we had a slide. I thought there was another slide. There it is right there. I had an updated one, and we've got one with a map on it. There you go. That's the second half of it. So Build-A-Bid is the 28th of this month. I was asked last week what time, what was the time. The sign-ups, they want you there at 8:45 in the morning. The last time we did it, we started like right at 9 o'clock. They kind of assign people, and then we work until we build the certain number of beds that they plan on building that day. We were done by 11. And they put people in different areas depending on their Their skill level, they have sanders, they have stainers, they have cutters, they have drillers, they have all sorts of different stations. It's kind of fun. This is going to all of the Rotary clubs in the Tri-Valley, so we're not going to be the only ones there, but it would be nice to have some of us there to be able to represent our awesome meeting. So in the sanding areas, if you are worried about sawdust, dust in the air, stuff like that, maybe bring a mask if you sign up for it, just as a precaution. But it's kind of neat to see these things, and then they feed you afterwards. So I did update the link on the page so it gets you directly to where you register. And we're not passing out a clipboard with a sign-up sheet because you guys need to sign up and sign the waiver that you're going to be responsible and not cut off any fingers or anything like that. Yeah. You won't be working with those. That they're supervised by skilled craftsmen. So yeah.
Thank you, Trucks. So we lost Paul Benke on October 1st of 2025 from injuries suffered in an accident. Just want you all to know that a celebration of life will be held Saturday, March 7th from 2 p.m. to 4 p.m. at the farmhouse, not here, but of course, the farmhouse at the Alameda County Fairgrounds. And next, we're going to pass on brag and boast.
You have a little bit of time if you have a quick one.
Okay, good. Quick brag and boast. Oh, right there.
Guess what? I'm a grandma.
You're a grandma. Congratulations.
As of Wednesday, my soon-to-be husband's oldest daughter gave us our first grand squish, and his name is Arthur.
Oh, wonderful.
Congratulations.
Congratulations.
So yeah, I'll do a brag too. One more brag. So last weekend, Troop 939 did a flag retirement ceremony for the Elks Lodge and VFW over at the Elks Lodge. They actually approached me 3 or 4 months ago, and we had a nice turnout with Elks and veterans and scouts. So it was a nice event, and they had never seen one before it. So they enjoyed it, and they want to do more of them. So shout out to Troop 939.
It's good to hear that.
All right, Pat, I guess I have to brag too.
Okay.
I have a double brag.
I'll bet.
So first, my maybe I'll go for 3. Last night, my nonprofit hosted a poker tournament along with Kids Diabetes Foundation, and we sold out and raised over $10,000 last night.
Wow, 10,000! Wonderful.
So that was a great event. Thanks to everyone who donated and helped out. My second brag is my sister speaking.
Wonderful. You can't beat that. And she's here with your mom and dad. That's even more amazing. So next week's program, we have Angela Plummer. Joel, were you going to talk about this one? I didn't know if you were up or I was up on this one.
Well, Phil and I were at the Dublin Club meeting a couple of months ago. And Angela Plummer was a speaker there. She's talking about Team Esteem, which is a program to get kids off of their phones or not to worry so much about social media. It's killing teens, and it's just really ruining the lives of a lot of middle school and high school age kids. So she runs an organization, this Team Esteem, that tries to address the problem. She'll be talking to us next week at the lunch meeting.
Thank you, President-elect Joel. This week's meeting features Dr. Janice Bishop, and I'll turn it over to...
I get to read the introduction. This is cool. Dr. Janice Bishop is a chemist. Yay, a chemist. I'm sorry, that was me too. And planetary scientist who explores Mars, the Moon, and other planetary bodies using spectroscopy. Yay! I'm sorry, you can't be a chemist and not do spectroscopy. So, and geochemistry. She has degrees in chemistry and earth science from Stanford University and a PhD in chemistry with a joint thesis project in planetary geology from Brown. She received a fellowship from the Humboldt Foundation in Germany for a postdoc at the German Aerospace Center in Berlin, and then a National Research Council fellowship at NASA Ames in California, where she currently works. Is that right? Yeah.
Sounds good.
You're next. She has been at the SETI Institute since 1999 and also a contractor at NASA Ames. More recently, she was selected as a fellow of the Geological Society of America, the Mineralogical Society of America, and the American Geophysical Union for her work on spectroscopy and mineralogy of the planet Mars. She has also received several awards for her work, including GSA's Gilbert Award and Day Medal. Janice's group uses reflectance spectroscopy at visible and infrared wavelengths to probe the structures of minerals. Her group also investigates field sites, including basaltic volcanoes, evaporites, and cold deserts. These enable her to document the geochemical processes producing the minerals observed on other planets. She studies the fingerprints of minerals and analog materials in the lab and field to generate spectral libraries for identification of those materials on rocky bodies of our solar system. In many cases, orbital spectrometers provide the only means of determining what's in the minerals down there. Okay, so investigation of Mars through remote spectral imaging has been integral to unraveling current and past environments and has played a prominent role in site selection for landing missions. Dr. Bishop.
Well, I'm happy to be here today and see a bunch of friendly faces from the past and from the far past and the not so distant past. So let's get going. I work at the SETI Institute. I also have a NASA badge, and NASA Ames is about 2 miles away, and I have meetings there frequently, but my lab is now at the SETI Institute, which is in Mountain View. Our mission is to lead humanity's quest to understand the origins and prevalence of life and intelligence in the universe. And we have 6 different groups. The original SETI Institute was the SETI Search for Intelligent Life, and now that's about 3% of the science we do. And these other things encompass a lot more of what we do. Exoplanets, looking for planets around stars and other stars in our galaxy and other galaxies. Astrophysics, heliophysics, which is studying our sun. Planetary exploration, which is a little closer, that's what I do. And astrobiology is something I also do, looking for the origin of life here on Earth or potentially on other places as well. Everything at the SETI Institute finds a home somewhere in this Drake equation. And this was from our founder, Frank Drake. And this equation approximately tells us the chance of meeting intelligent life somewhere else. It could be in our galaxy, or this equation's for our galaxy, but we have a number of generally vague components here. So how many stars are there, and how many stars have planets? How many of those planets have an environment that could support life? And that's, let's see, is this, no.
There's not a laser.
Oh, there's not. Okay. Where the red circle is there, that's what I do. That's identifying planets that have an environment that could support life. And then of those, which planets actually form life, which have intelligent life, and which have intelligent life that could communicate. And then L is the length of time. And I think this is the most interesting because on our planet, humans have been here for a little while, but not very long compared to the 4.5 billion years of our planet. But the length of time we've been able to communicate outwards from our planet is maybe 100 years. When you think about radio, TV, I think somebody said I Love Lucy was the first television show that was broadcast, enough that it could be heard from space. So that's what the aliens might be thinking of us when, they get this first I Love Lucy. So in any case, when we're trying to reach out to other potential civilizations, we have to catch them in it doesn't just matter that they have intelligent life, they must have intelligent life that's communicating. And of our 4.5 billion history, right now we've only had about 100 years, and who knows, how long we're going to have intelligent life on our planet. With the way we're going, we might be blowing our planet up. So, we might not have life here for very long. So we'll see. In any case, what I do is study the planet Mars, and also a little bit moon and asteroids. But what do we know about Mars? Mars is the 4th planet, and it's can I take this?
Yes. Pull it out.
Okay, there. So Mars is the 4th planet here, just past Earth. And if you look at the sizes of the Earth, the Moon, and Mars, it'll help you understand Mars is about half the diameter of Earth and about double the diameter of the Moon. So it kind of fits in between there. And if you look at some comparisons between the Earth and Mars, we describe the distance from the Sun to the Earth as 1 astronomical unit, or 1 AU, and Mars is about 1.5. And the period of orbit is 365.25 days, as we all know here. Well, Mars is almost double, not quite, 687 days. So some of you may have been noticing we launch to Mars about every 2 years. If we're lucky, if we can get that many launches. But it's because the orbit of the Earth goes around once and Mars goes around. So Mars goes around once while Earth goes around twice, approximately. And so we shoot any mission a little bit before they're going to be overlapping. It takes about 6 months, so about 3 months before that point where they're going to be close. And then that's the way that we can arrive most efficiently. The period of rotation on Earth that we're all familiar with is 24 hours. On Mars, it's about 24.5 hours, which you'd think, oh, that's about the same. And it's pretty close, but if you think after 2 days, you've added an hour. After a week, you've added about 4 hours. So if you're working on a rover team and you're living on Mars time, pretty soon, your day is there, it's going to be night from your family and everybody outside, so it gets a little crazy working with that. And if you think about the atmospheres between Earth and Mars, we have basically the same components, nitrogen, oxygen, argon, and carbon dioxide. But on Earth, nitrogen is our most abundant component of the atmosphere, whereas on Mars, carbon dioxide is the most abundant. And our atmosphere is defined as 1 bar, 1 atmosphere, and on Mars it's much thinner. So it varies a little bit, but about 1 to 10 millibars. So if you think of hiking at the tallest mountain, you remember and how the oxygen was a little thinner and maybe had to breathe a little more. So if you go to Mars, it's even more extreme than that. So the atmosphere is pretty thin. So you would actually probably need to have an oxygen supply. I don't think it would. Besides the cold and the radiation, the thin atmosphere, there are a lot of challenges there. So what is Mars like in general? It's similar to Earth in some ways, that we have a North Pole and a South Pole, and both of them have polar caps with frozen CO2 and frozen H2O, and similar to the frozen water we have on our planet. And currently there's no water on the surface. It would just sublime, which means goes from a solid to a gas, because it's too dry. And there are frequent dust storms. So if you look at these different images, sometimes when they look at Mars with a telescope, it's just covered with this reddish dust because of the dust storms. And if we look at Mars sort of over history, back towards 4.5 billion years at the beginning, we know there was liquid water because we see giant water-carved features like the Grand Canyon and other kinds of valley networks. And we also see minerals which formed in the presence of water. And so we know there was water, and we know it was there for a while. But today it's a pretty barren desert. So a lot of these interesting minerals that were formed and provide evidence, the clues we need to retrace that history, they're buried. And so we don't have road cuts or diggers that can go out and scoop that up. Instead, we have impact craters. So a lot of asteroids have hit the surface and they impact the bottom and throw the material up, and then we can see what was below the surface because of that. We've had several missions going to Mars, and since Viking in the 70s, there was sort of a gap for a while, and then Pathfinder in 97, and then since then we've had several more from NASA and from the Europeans. And this is a map of Mars back here. This is, I think that's okay, flattened out, and you can see where the missions have, the landed missions have occurred with the blue location. So the southern part of Mars is higher elevation, and this map shows lower things are in blue, higher things are green, yellow, red, and white are the highest mountains. And so the southern part of the planet is a higher elevation, and you can see all of these impact craters, so all these sort of circular features, those are from impacts hitting the surface. And the north is very dusty, and some people think there might have been an ocean there. There might have been, might not have been. We don't know, because it's covered with dust, we can't really see it. But that's one of the, one of the fun things about working on studying Mars is many things we can't answer. So you can hypothesize. You can bring all of your arguments. It's kind of like attorneys sometimes hypothesize all these things that might have happened and try to, so it's often almost political at conferences that people bring their arguments and try to persuade other scientists to believe their, and we can't really know the answer until we send more missions or send humans to figure it out. And this is the Mars Pathfinder rover. It was the first rover that was successful on the surface. And this was an engineering demonstration, and fortunately some scientists convinced them to put a few cameras on board and get some chemistry as well. And then the twin Mars exploration rovers arrived in 2004, and these, they couldn't decide on the exact location, and there had been so many problems with missions failing, they thought, oh, we'll send two. And so hopefully one will make it, and fortunately both did. And they generally have a camera that has 3 or 4 channels, and this works a little bit like our eyes, so a spectrometer that we already heard about. Everybody, probably most of you in this room have 3 colors you can see with your eyes, red, green, and blue, and your brain processes this information and tells you what color things are. So cameras that are on rovers or orbiters can also do this. So minerals in the top left, those are the colors of different kinds of iron oxide minerals, and then the spectra of what they look like. And then we won't be getting all those channels from these cameras, but we'll be getting about 3, and so we can still see differences. And something interesting happened with the Spirit rover. It had driven across this barren-looking desert and wasn't too interesting, and it had been driving along, decided, okay, we're going to turn around and take a picture of where we were before we go on. And of the 6 wheels, 5 were working really well and rolling properly, but 1 wheel kind of got stuck, and kind of as it was going, it was kind of dragging this 1/6 wheel, which was super fortunate, because when that rover turned around to take its back little picture before it went on, it was like, what's all that white stuff right below the surface? We don't know. Okay, so they went back and they looked at it, and it took all the little instruments they had on board and analyzed as best they could, and found a lot of sulfur and phosphorus rich mineral, and some with high silica, right underneath the surface that they wouldn't have known about if that wheel hadn't gotten stuck. So sometimes a problem can be fortuitous. So that was very lucky in that case. And then this is how we process this information, the camera on this rover had 10 channels, and so we can only see 3 at a time with the red, green, blues, so we select different combinations of these wavelengths in order to compare the different minerals that are present and try to understand what kind of sulfate or what kind of phosphate is present. And then the Mars Reconnaissance Orbiter is something I worked with more, and we have nested instruments is what they call them. CRISM is the spectrometer. It's kind of a play on PRISM. It's called CRISM, Compact Reconnaissance Imaging Spectrometer for Mars. And inside the CRISM, I'll take this here. So CRISM is this red box here. HiRISE is the yellow box, and CTX is this one. So CTX is the context, so it gives you a bigger image to show you what you're looking at with the spectrometer. And the HiRISE is the high resolution one that could see your car on a driveway, for example. So this is an example of what HiRISE can see. It's not quite like Google Mars, but at the time we started in 2006, it was pretty good. There weren't a lot of imaging capabilities for Earth. At that time, we could, not really, but we could almost see better on Mars. Probably there were some places. So it's down to 20 to 30 centimeters. So definitely, if HiRISE was looking at Earth, they could tell if there was a car in your driveway and probably tell what color it was and what kind of car, but they wouldn't be able to read your license plate. So. And then what I work with is CRISM. And in this case, we have an image, like a camera image, but not just 3 or 10 channels, we have 544 channels. So for every little spot in that picture, we have over 500 channels. And so we get what I call a spectral fingerprint. So these curvy lines. So minerals have different absorptions due to different properties, and then we can identify them through these wiggles in their spectrum. And so how does spectroscopy work? We need 2 hands sometimes. So we need to have a light source, so it can be the sun shining on a surface, which can be a rock or a table or a chair or a human or a grass or whatever, but the sun shines on that surface, and then the molecules in that surface are absorbing light at energies that match the vibrations of the molecules. And so when the light shines on it, some of that energy is absorbed and some is reflected. So we get then these curves here, and where we see the bands here, that's where the energy from the sun matches the vibration of the molecules. And so that's what we're looking for. So then, what is a mineral? A mineral is a combination of atoms that are in a unique crystal structure, and rocks are composed of these minerals, kind of like molecules are composed of atoms. And so things like olivine or gypsum or hematite or clay, and each of these has unique properties. Some are made into jewelry, which look beautiful. Gypsum is used in cement, and clays can be used in cosmetics or cat litter. So they're all important, so in one way or another. And so how do we identify these then? These atoms that are connected with bonds inside the mineral structure, they can have stretching or bending vibrations, and the stretching can be symmetric or it can be asymmetric. So you can have a whole little dance to explain what's going on with your mineral and its vibrations, but that's how we can identify these then on Mars or somewhere else. So this is our map of Mars again, and here we have several different types of minerals in different colors. And the point of this is to show you, these are all sort of alteration minerals. So one of the things I'm most interested in are these alteration minerals, clays and sulfates and carbonates, phosphates, these things that form as the minerals alter in water and under different conditions, because those tell us about the environmental history, the aqueous geochemical history. And so with CRISM, we're able to generate these images. These are from projects I've done with various different colleagues. And we use different colors to render these, to show the minerals that we're trying to. to try to show them in a picture, we need to map them in different colors. So like on the right, we're mapping this lower right, the olivine or the primary silicate minerals, sort of the boring stuff that's unreacted, that's in green. And then the clays that I'm interested in, those are mapped in blue, purple, pink, and red. And so we pick these different colors, kind of stretch the RGB a little bit to show a little more in order to look at differences in these clays. And one of the places I'm most interested in is called Marth Vallis, because it has a lot of clays. And clays are super interesting because they can also bind organics. And those are necessary for origin of life. So one of the things we do at Marth Vallis then is look at these clay signatures, these spectral signatures, and we can map something called an iron smectite clay or an aluminum smectite clay. And in this region, we found it kind of forms like a deli sandwich. So we always have this iron clay on the bottom of the sandwich, and we always have the aluminum clay on the top. And then in the middle, we have different things, so different kinds of sulfates or other clays sometimes. So it could be like having a ham sandwich one day and a turkey sandwich another day. So across this region, we always see the same thing on the top and bottom, but I think the stuff we see in the middle and the variations are due to changing conditions, changing environmental conditions. So other places CRISM has looked has been where rovers have gone. Every time we choose another landing site for a rover, we look at the CRISM images and we look at the mineralogy, and one of these places is called Gale Crater. And so that's the CRISM images on the right, and there's the rover, and this is the rover that has a chemistry lab on board and is identifying organics and also has an X-ray diffraction unit. And then there's another rover it's called Perseverance at Jezero Crater. This is the most recent one. And you could see the rotors going on the helicopter. This is the first time NASA sent a helicopter to Mars. And I figure we might have some engineers in the room, so I put that in. And the picture at the top left, that was taken by the helicopter, which is kind of cool. So this was another sort of engineering demo. And here's the helicopter on the right, tracing up the pink, and then it'll go across. So initially they didn't know if the helicopter would even fly because the atmosphere is so thin, but they managed it, so that was great. And hopefully they'll be able to have those again in future missions. The handy thing with a helicopter or a drone, from the rover, has to prod along like a little turtle going, one direction or another, and the drone or the helicopter can go up and look, and it's like, hey guys, over there, that's the really cool stuff. And so we need to find a way to get over there, so that really helps with the navigation. This is, again, CRISM minerals mapped from orbit across Jezero Crater. And what we wanted to do with the mission was determine, are the minerals we see outside the same as the minerals we see inside? Or did the minerals inside get somehow changed by sitting in this paleo lake? So was the water inside Jezero Crater able to change the mineralogy, and if so, how did it change the mineralogy? And so how do we interpret all these CRISM spectra? Well, we go to analog sites, so like Antarctica, cold deserts, or volcanic islands, or hydrothermal settings like Yellowstone. And in the Antarctic dry valleys, we have permanently frozen lakes, which are interesting with oxic water and anoxic water, and we have microbes and clays, and that's a whole nother different story for another day, but I'm happy to talk about that. And there are a lot of volcanic islands that are very different in their climate and the kind of rocks that form. And so we often take magnets or spectrometers in the field to try to identify the rocks and bring back the ones that are most interesting for our projects. You'll notice in these there aren't very many plants. So we try to go to remote places where there aren't a lot of plants and there aren't a lot of humans leaving trash. So we try to just look at the rocks, how they've altered without the help of humans. And this is from the Painted Desert, where we actually set up an imaging spectrometer to mimic sort of what a rover could do, and then took spectra up one of these hillsides of different places. So putting together these minerals, we see different kinds of clays and iron oxides and sulfates from different environments can help us understand the environments when we identified these minerals on Mars. So going back to Mars then, these are a couple of places from Marth-Valles where I have red as the clay mineral, and so the red is the iron clay at the bottom, and the blue is the aluminum clay at the top, and there are these green patches which are different kinds of sulfates in between. And then we can use this at Jezero Crater as well. Again, the colors here are from the clays and the carbonates and the olivine that we see from orbit. And the yellow is where Perseverance landed here, and it drove a little round, and then it went out this way. This spot right here called Bright Angel, they name things kind of weird things. It's confusing for most of the world, but instead of saying Rock 1 or Rock 239 or Rock 4290, then they have these weird names, and that's how they keep track. In any case, in this Bright Angel region, they found some really interesting rocks. So there are these reddish mudstones, and they're red because they have ferric iron. And then they found these little green and white spots, and they decided to call them poppy seeds and leopard